Hi folks, so we are going to start working with CircuitPython on the Circuit Playground Express. Now CircuitPython is based on the very popular Python programming language. The folks at Adafruit have just added hardware support so that it can work with a microcontroller. Now according to some studies, Python is, and this one says Python is the top programming language that you can learn. Most computer science programs in the country start off their students learning Python. It's a very popular language for big data use, for data analytics as well. And while we don't get everything that we get with traditional Python and Circuit Playground, we also get a lot of other stuff to be able to control the hardware. What's also neat is all of these different boards here, and we're using again the Circuit Playground Express. They're what's called Arduino compatible, and traditionally you've programmed these kinds of devices in C++, but we've already learned how to program them in MakeCode, and now we're going to program them in Python, which is actually a lot more practical. Hopefully you'll find that easier to use than if we were to jump right into C++. And this hopefully will be all that you needed to use as well to get your Circuit Playground Express to do lots of really neat things. Now, the Circuit Playground Express needs to be configured so that it can run this CircuitPython stuff. So let's go ahead and do that. What we're going to do is we're going to hop over to our browser. We're going to actually look for the page that says Welcome to CircuitPython. And this should bring us to the Adafruit page. We can see we're on Learn Adafruit here. It says Welcome to CircuitPython. This is our overview page here. What we want to do, looking down on the side here, is we want to find the page that says Installing CircuitPython. So in my browser here, it's the second one down. I'm going to click on that, and we see download the latest version. So what we're going to do is we're going to download the latest version of CircuitPython software. I'm going to click on this green button here. And this brings me over to a site called GitHub. GitHub is owned by Microsoft. It's actually a repository where programmers put code that they've written. If you have a programming course, your professor may use GitHub to submit programming examples. That's what we do in the iOS Swift course that I run. But what we're going to do down here is take a look at the various different types of CircuitPython that are available. You want to get the very latest one. So the latest one, when I'm recording this video here, is the second option. And again, you want to download the one for Circuit Playground Express. So I'm going to click on this, and I'm going to save it to my desktop and click on Save. And what's going to happen is it's going to download the UTF file. So that's a file that we want to go ahead and put on our CircuitPython Express when we plug it in. I'm going to download one more thing as well, though. So I'm going to press my backspace button after the UTF is downloaded. And I'm going to look down here for something that says libraries. Now, what Adafruit has done is they put together a bunch of additional pieces of software written in Python so that we don't have to write things from scratch, so that we can already access things like the various sensors on the device and the different lights and whatnot. So we're going to click on this thing that says CircuitPython libraries. You see, I've gone back to our welcome listing here on the left-hand side. Click on, again, CircuitPython libraries. And by the way, you can go through these instructions if you ever run into some difficulty installing, but hopefully these instructions work fine for you, regardless of whether you're using Windows or the Mac. So it says installing the CircuitPython library bundle. I'm going to click right on this one here. And I'm going to take a look for the latest releases that we've got, and we've got all different kinds that are right here. And I see we're using the latest version of CircuitPython, which is called CircuitPython 3. That's what I just downloaded, so you want to make sure that your library is compatible with that. And just to verify, if I hop back over to the Finder on my Macintosh here to take a look at the desktop, you see how this says 3 at the end? It is quite possible by the time that you're watching this video that there may be a CircuitPython 4, but when I record this, 3 is the latest version of this. And so I want to get the libraries that say 3 in here, not the one that say 2. I'm going to click on this guy here. It's going to offer to download it. I'm going to say Save. It's going to bring it all down to the desktop, and now that I've downloaded, I can go ahead and minimize my browser. I can see my files on the desktop, and what I'm going to do now is I'm going to hook things up in my Circuit Playground Express. So I've already plugged in my USB cable into my computer. I'm using a Mac, and now I'm going to plug it right into the CPX here. Now, what you might see on your CPX changes just a little bit. I happen to be in Bootloader Mode right away. That's when the green lights are showing. If your green lights aren't showing, you can press the reset button just a couple of times, and that should show up. Sometimes you have to tap it twice very quickly. And then what you should see on screen is you probably will see a CPlay boot which shows up. Now, if you have a Mac, by the way, and you see this disk not ejected properly, there's no reason to worry about that. That's just something that shows up because the Mac isn't used to having a microcontroller attached to it. But we've got the CPlay boot right here. One of the first things that we're going to do is we're going to grab this CircuitPython UF2 file and put it right into CPlay boot. watch what happens when I let go there and it copies it over. So I should get a message that it's copying it over, and I get a disk ejected, not ejected properly, but that's fine. I can just say close. There's really nothing that's a problem. And then on my Mac, I see right away now it's called CircuitPy for CircuitPython in here. Now you should only have to install your CircuitPython once, but if you go back and forth between, say, the Arduino programming environment or MakeCode, and your microcontroller isn't showing up with CircuitPy when you plug it in, you may have to go ahead and reinstall that. So you might want to keep the files fresh on your desktop. You might also be wondering, hey, how often do I have to go ahead and update my Circuit Playground Express with different Python files? And you actually, if everything is working fine in projects that you're working on, there's not a real need to continue to update stuff. But if you're starting from scratch, it's a good idea to use the latest version of CircuitPython, so I always check mine before I start a new project. And the reason for that is, maybe they've got some stuff that has been fixed, if there were some bugs in the product, or maybe there are new libraries that I want to use that can do some really neat stuff. If you want to check the version that's installed on your machine, so if you've already got one installed in your Circuit Playground Express, I've double-clicked to open up the Circuit Playground Express, and now I'm going to click on this boot_out.txt file. The reason that I'm going to do that is it shows up and it tells me what the version of my Circuit Playground Express is. So this says 3.0.2 because that's the version that I just copied over right here. You can see if I hover my cursor over, it actually says that's the name of the file itself. So I'm using the latest version, not surprisingly, because I just dragged it over. Now the other thing that we want to do with our Circuit Playground in here is we want to drag over the latest version of our Circuit Playground libraries. So I'm going to double click on this. And this is going to expand, and I get a new folder here which says LIB for library on there. And now what I'm going to do is I'm just going to drag the LIB folder inside of my CircuitPython. I'm going to let go. The LIB folder will start to show up there. It's going to copy over a bunch of folders. It might take about a minute, but once this is done, you'll be all set up to start working with CircuitPython on your Circuit Playground Express. And since copying over is going to take a little while, I'll just pause and then get back into it when my files have all been copied. And everything has been loaded up. And I can close these two windows here, and I'm going to return to my browser. Now, in the way that you create word processing documents using a word processor or spreadsheets using a program like Excel, we create programs that we write using what's called an integrated development environment. It's just a place where we program. And there's usually information in there to allow us to edit our programs, to give us help if we run into a bug or we've got an error in there. There's typically help information. And in the case of Circuit Playground Express, what we're going to be using is an integrated development environment called Mu. So I'm back in the Welcome to CircuitPython section of the Adafruit website, and I'm going to scroll down here where it says installing the Mu editor on the left-hand side, and I'm going to click on that. Now there are other Python editors that are available. Many of them have a bunch of features that Mu doesn't have, but the reason why we're using Mu is number one, it's free, but even more importantly, it works very, very well with Circuit Playground Express. And in fact, we will see that we've got a connection called a serial monitor, which will actually show us what's executing on the Circuit Playground Express so that we can see that on the Mac or the Windows or whatever other computer that you're using. We'll also see that there is a plot function, so we can actually plot data that we get from the Circuit Playground Express in real time from, let's say, the different sensors in the accelerometer or the light sensor or temperature sensor or things like that. So in order to go ahead and install Mu, what we're going to do is you can see on this page you've got some installation instructions, and you can actually just go ahead and find those that are applicable for whatever computer that you're using. Now, it says right here to install Mu for Windows or Mac OS, go to the Download Mu page, so I'm going to click on that. And if you have a Windows computer, I'm going to leave you on your own, just assuming that you know how to go ahead and download things. And again, there are instructions there too. If you're using a fairly late Windows computer, especially something with Windows 10, you can probably click on the 64-bit, but again, follow the instructions. I'm just going to click on download for the Mac version here. It's going to offer to save it to the desktop. I'm just going to click on save. And once it's downloaded down here, I notice it in Chrome, I can minimize my browser and I can find where it says Mu. On the Mac, it happens to be a DMG file. On Windows, again, it should say in the instructions exactly what you've got to do if you've got to uncompress a file, or if just you go ahead and double click to install like I'm doing here. I'm just going to agree to the license. It will go ahead and install Mu for me here. And I actually have Mu installed on my computer, but I'm just going to overwrite the version that I've got on here. And I'll show you how I set things up on my Mac too, which make things a little bit easier for me to go ahead and do this. And it'll be pretty quickly, so Windows users, you can fast forward, but we should be done. It says Mu Editor right here. Notice it opens up the standard Mac installation program here. So what I'm going to do is I'm just going to drag where it says Mu Editor over into my applications file and let go. This is preparing to copy over to applications, and we'll see it'll copy over again. It'll take a little while here, so what I'm going to do is just pause this video and I'll get back to it in a bit. And it's just gone ahead and copied that over. So now I'm going to click and close this installation window. I've opened my applications folder here. It's usually on the Mac, it's on the left-hand side. And in here, I'm going to go ahead and look for Mu. If I actually type in MU, it'll jump to it already. There's this little picture of a Python in here. And one of the things that I like to do is to put the editor in my dock so that I can access it very quickly. So again, it's up to you if you prefer that, but I'm just going to drag it down in here. It will keep it in the applications folder, but it'll just put a copy in the dock. And what I'm going to do is I'm going to put it right in between. I have Xcode in the Arduino development environment. You may not have that on your machine, but now I can use Mu whenever I want. And so I no longer need to have my applications window open, and I can actually drag this Mu editor and throw that in the trash. I can drag the DMG and throw it in the trash too. I don't need those things. And as I mentioned, you might want to save the .uf2 file if you need to reinstall CircuitPython on your machine, especially if you're switching between MakeCode and Arduino or anything like that. But you can get rid of the zip file. You don't need that. And you know what? I've added a little jump cut in here because I thought it would be useful to show you. Again, if we get in and we use MakeCode again, it may wipe out the CircuitPython stuff. So what I'm going to do is I'm going to create a folder where I put in the backup of CircuitPython and I put in the backup of the library, just so that if I start MakeCode and then CircuitPy goes away, then I can just drag that stuff out of the folder, plop it in here, and I'll be good to go with my CircuitPython stuff. So what I'm going to do here on my Mac is I'm just going to create a new folder, and I'm going to call this CircuitPython backup files. You can call it whatever you want. I'm going to drag my lib in there, and I'm also going to drag my Adafruit Circuit Playground, the uf2.uf2 file in there as well. Now, just to show you, you don't have to follow along with this part, but what would happen if I went into MakeCode? So here I am, I'm in MakeCode, and I just pulled up a little code example in here, which just if you click on the A button, what it'll do is it'll start the rainbow animation or end the rainbow animation. And if I click on download, I have my Circuit Playground plugged in. Note that it's saying CircuitPy right now, but if I click on my device, which you're not seeing here, and I press on reset, and CircuitPy goes away, you can see on the Mac you get the disk not ejected properly in the upper right-hand corner. I'll just close this. Now what I'm going to do is I'm going to press the reset button on my Circuit Playground Express twice very quickly. And you're not seeing this, but what it does is it puts it in bootloader mode. I once again get the disk not ejected properly. Again, always ignore that. You'll only see it on the Mac. But I see it says C Play Boot now. It doesn't say CircuitPython anymore. I can click on this, and this will bring me right into my Circuit Playground Express. I can give this file whatever name I want. I'm going to call it Rainbow and select Save. And now what I can do is I can close up my window, get rid of disk ejected improperly. Just to show you that this is working, if I go ahead and press button A, you can see the rainbow starts and stops. So that's just to show you that the code is working fine. But now the issue that I've got is I don't have my Circuit Playground or my CircuitPython files in my Circuit Playground Express anymore. So what I'm going to do is I'll simply tap twice on the device, or maybe just tap once. I'll get into Bootloader Mode. You'll see that the lights will turn green. If you take a look over on your computer desktop, you should see that the C Play Boot shows up as well. I'm going to get into this folder that I just created with the backup files here. I'm going to drag in my UF2 file right into C Play Boot. I should see that that gets ejected and goes away after it's been copied, so I can close that, and then it turns into CircuitPy again. I should have my libraries already in here, lib, so I don't need to copy those over, but I've got those in my backup just in case. Everything is fine. So just you've seen this. If you want to switch between MakeCode and then back to CircuitPython, now you know how to do that. Just drag your UF2 file over. Now, that said, what I'm going to do is I'm going to launch my Mu editor right here. And it might take a little while to load up, and I'll open this up to full screen so that you can see everything nice and big, and let's write our first Python program and save it onto our Circuit Playground Express. Now what I'm going to do so that you can see things better is I'm going to hold down on my Mac, it's Shift, Command, and plus, and I'm going to press that a few times, and what that's going to do is it's going to make my text much larger, so hopefully it's easier for you to see. You certainly don't have to do that if you decide you want to shrink things down. In fact, on the Mac it's just Command minus, so it's probably Control minus and Shift Control plus on Windows machines, but I'll just make this nice and big. Let's get started and turn you into a Python programmer. And mu gives us, whenever we start a new file here, this line of code that says $, write your code here. Now what the $sign means is that's a comment line, and it means don't execute anything on this line after the $sign. So this is a great way for you to document your code, and I would suggest that you use $sign comments quite frequently in your code, especially when you're writing things and you've never done them before, because this way if you pull up your old examples, you have some documentation in there that says, hey, this is how I accomplished it. So what I'm going to do first is I'm going to tell you a couple of lines that you're going to need in just about every Circuit Playground Express Python program that you write. And the first one starts with the word from, and then we type in Adafruit _ Circuit Playground .express, and then space, and then import, and then space, and then CPX. Now again, Python is going to be really picky about the precision of making sure that you've got the spelling correctly here. You don't have any extra characters that are in there, but what you need to remember is just, hey, I need this line in here because I'm working with a Circuit Playground Express, and I'm going to be able to refer to that as CPX in my code. And I'll show you how we'll do that in just a bit. We're going to import another library in here. I'm going to say the word import time and then press enter here. And the thing that's important to know about this is if you ever want to use a time function in your code, you've got to say, hey, import the time functions in here. Again, this might seem a little hairy here, but just about every time we're going to write code, we are going to need to refer to the Circuit Playground Express, and for consistency's sake, we're going to call it CPX. And almost every time we write code, we're going to use the time function, which allows us to sleep or to pause our code for a particular period of time if we want to, wait in between actions. So it's probably a safe bet. Once you've got this working, you can just copy and paste these two lines or re-enter them in every bit of code that you've got. Now, I'll give myself just a little space here. I'll press enter one more time. And on line 5 here, what I'm going to do is I'm going to write the equivalent of the forever loop in make code. Remember the make code forever loop just went around and around and around and executed this forever? Well, what we type in Python to get a forever loop in here is we say while true and then a colon. That's the dot on top of the dot. Now, what a while loop does is it executes everything after the colon as long as it's true. So normally you might evaluate something like, has button A been pressed, or is your animate variable set to be true, which are some of the things that we did in make code. But when we say while true, we're essentially saying is while true is true, which is always true. I know that sounds weird, but just know if you do while true colon, that's a forever loop. Now if I press enter here, notice that mu automatically indents this, and everything which is indented here underneath the true will execute as a unit. So every time I say while true, which is always going to be true, it'll go ahead and execute all these indented lines underneath it. Now the very first thing that we're going to do is we're going to say, hey, let's turn on all the red pixels in our CPX. And I'll show you how we do this. First, to refer to the CPX, we say CPX, and then I type in a dot in here. And then to refer to all of the pixels, meaning all of the little lights in the Circuit Playground Express, they call them pixels, we'll say pixels. And then we're going to say dot and then the word fill. And so this is a command that says go into the CPX and for all of the pixels, fill them. Now, whenever I pass some data into these particular functions that are associated with the CPX, I'm going to open a parenthesis here and I'm going to close a parenthesis. And then in between the open parenthesis and the close parenthesis, I'm going to send in some values. Now what's a little tricky here is I'm going to do another open and close parenthesis in here to send the color value in. Now there are lots of different ways that you can express a color value, but the reason why I did this second set of parentheses in here is I'm going to use the RGB values. And RGB means you can express any color in the spectrum by giving it a value of how much red is in it, how much green is in it, and how much blue is in it. And I know that sounds kind of weird because you learned about yellow being a primary color when you were in elementary school, but RGB is how a lot of computers express colors. There are different ways too, but we'll use this one as a standard one. And if there's a 0 in either the R value, the G value, or the B value, that means there's no R, G, or B. If there's 255, that means it's as saturated as it can be with that red, green, green or blue value. So if I want to show just red, I'm going to say, again, I've got parenthesis and then parenthesis. I'm going to say 255, 0, 0. And so this inner set of parentheses in here where it's parentheses 25500, that's my way that I set up a color. And I used RGB for this. And then in the outer set of parentheses, I pass that color into fill, say light up all the colors in Circuit Playground Express. Then what I'm going to do is I'm going to click at the end of my line and press enter. Again, notice it remains indented here. And then I'm going to say time.sleep open parentheses and say 0.5. So I want this to delay for me. And our delay is going to be half of a second. So that's what the 0.5 is. And now I want you to think about this. Okay, so if this statement up here did an RGB value for red, green, and blue, and we use 255 for, say, all red, and then 0 for green and 0 for blue, how would you write the next two lines of code to say, okay, after I've waited half a second, now show just blue in all of the pixels or all of the little lights on the device? And once you pause, see if you can write it. And what you can do is unpause afterward, and I'll show you the solution. And we're back. And so what I'm going to do here is, I actually pressed enter in here, but what I can do that's even better is I'm just going to copy these two lines of code. I'm going to say Command-C on the Mac. It would probably be Control-C on Windows. Now I'm going to go to the new line. I'm going to do Command-V or Control-V in Windows. I've pasted the same two lines of code up here, but instead of saying red is 255, if I don't want red to show up, I say 0. And if I want blue to show up, then I say 255 for blue in here. Now, I can also go and click on the thumbs up here for check, and this will tell me, hey, if I've got errors or I should deal with anything afterward. And notice what I've got in here. When I did my RGB values in here, it says, hey, missing white space after commas. So it looks like it actually wants me, CircuitPython or Mu, I should say, wants me to put in a little white space after the number. Frankly, I don't think that you need that, but since it's asking for me to put in some white space after the commas in here, I'm going to go ahead and put that white space in. Then I'm going to say check with a thumbs up again. I see that I have no errors in here, so it's always nice to go ahead and do the check. You see the little hints right below it. If you have any errors in here, see if you can interpret it and compare with my code. And now what I'm going to do is I'm going to save this file. I'm going to save it two places. I'm going to save it so that I've got a copy locally on my computer, and then I'm going to save it to my CPX and execute it. So first thing is, you see where it says write your own code here, or that's our comment. What I'm going to do is I'm going to put a comment in here that has the name of what we're doing. So I'm going to keep the number sign there with a space after it, and I'm going to type in flash red and blue. So, you know, just to let me know what this does. And if I click on save right now, or what I do is I just double click on the tab here. It's probably a better thing to get into the habit of, because this will also allow you to select a location. It will do a save as, so you can save it to your Circuit Playground Express. But I'm just going to double click on the tab here. It says Untitled. All of a sudden I get my my standard file save dialog box here. I'm going to save mine to the desktop, and I'm going to create a new folder, and I'm going to say CPX Python code files. You can save that wherever you want, doesn't matter what you call it, but I just like to keep those organized. I'm going to say create here, and then I'm going to give this a name. I'll call it red underscore blue underscore flash, and then I'm just going to click on the save button. Now here's another thing that's a little bit tricky. What we're going to do now is we're going to save it to our Circuit Playground Express. So I'm going to double click once again on the tab up here that's now says R underscore blue or red underscore blue underscore flash. And I'm going to scroll down here until I see my CircuitPy. Remember that says you can, that's the name it has for your CPX when it's got CircuitPython installed on it. So I'm going to click on this guy, but we want to rename the file before we save it. And there are actually different ways that you can name a file that will be executed on your Circuit Playground Express. And instead of using any of the different ones to confuse you about that, I would say always save your code on your CPX as code.py. Just as an aside to let you know, you could also call it main.py or main.txt or code.txt, txt I should say, but Adafruit says, hey, let's standardize on code.py. Whatever you save as code.py, that will be the very first program that executes. So what I'm going to do is I'm going to go ahead and select the save button now. And this is going to save this to my CPX. And what you should notice is you'll see automatically the code starts to execute. So that's that code.py. And it flashes between the red light and the blue light. And it waits for half a second in between. So why don't you go ahead and see, if you can modify your code and then resave it down as code.py to your CPX and see if you can add a green light in between, or maybe change it so that it's waits a second in between initiating the flashes. So congratulations, you are now a Python programmer and you're programming microcontrollers, which sounds just magnificently geeky. But let's go over, I want to show you 3 more resources before we finish up this video too. One is in the first tab, and what I'm going to do is I'm going to link all of these in the description below the video so you can find them on your own, because they actually are a little tough to find through Googling. There's lots of things that have similar names. I wish things were a little bit more organized online, but in the first one here, if you look for CircuitPython or follow the link that I'm going to give you, CircuitPython Made Easy on the Circuit Playground Express. This is a bunch of really wonderful tutorial files, examples I should say, for you to try out things like the slide switch or the accelerometer or the temperature sensor or button pressing. So that's a great way to begin to experiment. Also over here I've got the Adafruit Circuit Playground Library, and what this does is it lists all of the things that you can do with your CPX code. So if you use that first line that we put into your code and with refer to things as CPX, and notice the line is right in here, you can see alphabetically down here all of the different statements that you can do in order to pay attention to whether or not button A has been pressed or button B has been pressed. In fact, if we go down here, we use the pixels, so it was CPX dot pixels in order to access some of the code here. You see some code happening right here as well. Different ways to express colors too, and you can see also where it says C neopixels.neopixel. If you click on this, what this will do is it will open another page. You can scroll down and see all the different things that you can do, like fill with a color or show or change the brightness or what have you. Now the last thing I'm going to show you is there's this file called Awesome CircuitPython on GitHub, and if you just scroll down here, you'll see the Blinka, who is the CircuitPython mascot, but also you'll see that a bunch of different things have been curated in here for guides, community, books, code, frameworks. So there's lots of great stuff for you to explore in here as you're trying to find out how to do some more things on your own. Also remember that Adafruit has a CircuitPython forums on their website. The response time behind posting questions up there is really quick. I've typically found I get an answer within a couple of hours, certainly within half a day. So I'd recommend you do all of these kinds of things, or be aware of all of these kinds of things as you're learning more on your own. Hope you feel really good about your skills, Python programmer. Keep at it.